Hello everyone, and welcome back to another mathematics and GIS tutorial video. And in this video, I'm going to talk about what happens when we have a vertical ellipse, right? That's one that is taller than it is wide, that is not centered at the origin. And I want to go through sort of the same thing we went through in the previous video, talking about where these parameters go. It's going to look very, very similar. It's just going to be rotated, just like the regular horizontal versus vertical, right? It's that same sort of concept. Now we're just shifting everything by h and k. So again, we have our center, our foci, our vertices, and our co-vertices. Just now keep in mind the vertices are vertical and the co-vertices are horizontal now. And so just like last time, right, our center is still h comma k, right? That's the distance that we had to go over and up to get to the center of the ellipse. Right, so now I want to talk about our vertices again. So if we scroll back over to our previous discussion, right, you'll see that in this case, to get to our vertice, this distance is still a, right? We had to go a, and we also had to go h. Well, now if we look at our vertical ellipse, right, to get to our top vertice up here, right, to get to our top vertice up here, right, first we have to go up k and then up a as well. So now this is going to have, wrong color. Right, again, because we're a vertical ellipse, right now we're talking about a is in the y-axis of our vertex. So our y-axis is now not just going to be a, but it's going to be a, and then we also have to go up that amount, k. And then our x-axis, right, how far we have to go over, right, that's just going to be h. So what about this one? Well, for this one in the y-axis, right, we have to go up k, and then we go back down a. So the y-coordinate of this is actually going to be k minus a, and then our x-coordinate is going to be h again. Right, so let's go ahead and formalize that. Right, the vertex has coordinates h comma a plus k and h comma k minus a. All right, and foci, again, following that exact same trend, right? In this case, to get to here, we had to go up k and then up c. So this is going to be h comma c plus k. And then to get here, right, you have to go over h, you have to go up k and then down c. So this is going to be h comma k minus c. All right, so our foci have coordinates of h comma, the top one has c plus k, and the bottom one has h comma k minus c. Okay, so now we can talk about our co-vertices. Our co-vertices, right, are the place where the ellipse hits the minor axis, which is the axis that cuts the ellipse in the shortest direction. Right? So to get to here, right, we go over h, right? We go over h, and we also go over b, which is what we defined as that distance. So the x-coordinate in this case is going to be b plus h. And the y-coordinate, right, to get up here, we just go up k. Right. In this, same sort of concept, right? To get here, we go over h, and then we go back c. So this is going to be h minus c, and then k. All right, so our co-vertex have coordinates of the right-hand one is b plus h, comma k, and the left coordinate is h minus b, comma k. Oh, actually, now that I'm looking at it, that should be h minus b, not h minus c. H minus b, comma k, because we're going over h, and then we're going back b. So again, same thing as before, right? You can see that the equation looks very similar, but how we actually get the a's, b's, and c's out of the coordinates is going to be a little bit more tricky. And so in the next video, we're going to look at how we can pull together an equation for a vertical ellipse not centered at the origin if we're given some of the parameters. Hopefully this video made sense. If anything was confusing, please go back and rewatch the parts you're confused about. And as always, please reach out. Thank you.